Our next examples are ones that will actually display a special case. And when we look at these exponent properties backwards, try to think of them as the same exponent properties we saw the very first day of class. Logarithms are the same as exponents. Same as our last few problems. If I let this equal x, then I can find out whatever x equals, that's what this log base 2 of 1 is going to equal. But now I have logarithmic form, base of 2 to the power of x equals 1. Well, when we think of what power of 2 gives me 1, go back to some of our really basic, remember that was 2 to the 0 power. And I know we want to say something like 2 to the first. Remember, 2 to the first is just 2. But our 0 exponent property said anything to the 0 was 1. When I have a base of 2, my exponents have to be equal, meaning x equals 0. Meaning log base 2 of 1 equals 0. Now, if we wanted to expand this out, remember what we could actually say is it didn't matter that that was a 2. That could have been a 3, a 4, 108. Whatever my base is, if I have a 1 as what's called the argument, if you want to know what that name is, the argument of a logarithm, log base b of 1, it's always going to equal 0. That's mirroring the same property we had at the beginning of class. Anything to the 0 power equals 1. That's what this property is going to mirror. And that's what's going to bail us out, kind of simplify some problems later, is whenever I can recognize a argument of 1, then I know it's just going to be a 0 and things are going to start canceling. Another nice property, what if I have log base 2 of 2? What if my argument equals my base? Well, let's see what's going on here. If I let this equal x, let's find out what x is. Let's find out what log base 2 of 2 is. This 2 to the power of x equals this 2. Well, I already have the same base. What is my exponent? There's no exponent there. Remember, it's 1. Almost deceptively easier. This tells me x equals 1. But remember, x equals 1 means if I have log base 2 of 2, that is 1. Anytime, and it wouldn't matter whether I have a 2, whether I have a 5, whether I have 110. Anytime my base equals my argument, it's an exponent of 1. A logarithm is an exponent. This mirrors, and we didn't even write this because it was almost too obvious, anything to the first power is always itself. That very basic property is what this is mirroring. And our logarithms are going to continue to just mirror our exponent properties because that's what a logarithm is. A logarithm is an exponent. So when you're solving for that exponent.